In this hopefully short video, we will take a look at surfaces in Vulkan. In a very similar way to OpenGL, Vulkan is operating system agnostic. The core API does not depend on the underlying windowing system, and in fact, in some cases the render target is an off-screen buffer, which means that there is no window at the end of the pipeline. Therefore, the Vulkan specification includes something which is called Window System Integration, or WSI, which defines the interaction between the core of Vulkan and the windowing system it is running on. The implementation of WSI is delegated to different extensions, one for each OS. The most important concept in WSI is the surface, which represents the abstraction of the native window. The handle for the surface is called the VK Surface KHR, and it is provided by the VK KHR surface extension, which we already enabled when we created the instance. In addition, we have enabled one of the OS-specific windowing extensions. This extension creates the surface and connects it to the native window. WSI defines a function for each operating system to create the surface. So we have support for Android as well as Wayland, which is a modern windowing system for Linux, Win32, XCB and Xlib on Linux, and I'm gonna stop here. You are encouraged to go over the rest of the list yourself. If you plan to run your app on a single platform, you can simply go ahead and create a surface using the specific API of that system. But if you want to keep your code OS independent and also make your life a bit easier, you can simply use a GLFW function to create the surface, and this is what we will use here. This function abstracts the OS and will work on every platform which supports GLFW and Vulkan, of course. Okay, we're going to be making changes in both the application and the Vulkan core library, so we have a new tutorial here, tutorial number 4. And to create the surface, we need a GLFW window, so we provide that to the application, to the init function, which brings us here, and then we provide that to the Vulkan core library, which brings us here to a function called createSurface, and then we call GLFW createWindowSurface. We provide the instance, the window, null for the allocator, and we also need to provide the address of the handle of the surface, which this function will create. So this guy is a VK Surface KHR defined here in the private section of the class. This handle will be used later on when we create the swap chain. Remember, the GLFW will create the surface using one of the extensions, one of the surface extensions that we have enabled here when we created the instance. Okay, so it's either for Win32, Apple, the Mac OS here, or Linux. And if you need it for any other system, make sure to put the correct one here. Of course, we also need to destroy the surface at the end of the program, and this is what we do in the destructor. But turns out the GLFW doesn't provide a function for that. We need to call the destroy surface function. Now this function is part of an extension, it's not part of Vulkan core, so we are actually calling it through a pointer. Same as what we did with the debugutils messenger, we need to get the address of this function, and then we can call it, passing in the instance, the surface, and null for the allocator. And if we run this and close the window, we can see that the surface was created, and then everything is destroyed in reversed order. Okay, I know I've said that this video will be about surfaces and physical devices, but I ended up separating the two topics, so you already know what the next video will be. Thanks for watching, and I'll see you in the next one.